triple sets. I hope that this video will be interesting for you if you are interested in things like intuitionistic sets, double sets, and maybe neutral-sophic crisp sets too. Basically, in this video, which is based on my paper that will be published in the newest issue, in the newest edition of Azure Mathematica. So in this video, we define the very concept of, I called them triple sets. And as you can read, they can be viewed as a bridge between intuitionistic and double sets. Perhaps you are already familiar with intuitionistic sets. Any set of this form is just like a pair of two classical sets that have empty intersection, while in case of double sets you have another pair of classical sets such that say A1 is contained in A2. And these triple sets, which will be defined in the next few minutes or rather seconds, they have some specific algebraic properties, they form some kind of non-classical logic, and we shall briefly analyze this properties. And of course you are encouraged to expand this concept, for example to investigate the notions of interior, closure, open set, and so on. So assume that we have a non-empty universe while A1, A2, and A3 are its subsets, such that A1 is contained in A2. So with respect to A1 and A2 we have so-called double or nested set, while A2 intersected with A3 gives us classical empty set. So this is like in case of intuitionistic sets. So then we can say that this triple is a triple set on X, A1, A2, A3. We say that triple set A is contained in triple set B if and only if A1 is contained in B1, A2 in B2, and B3 in A3. Of course, this whole definition has some interpretation, yes, in terms of logic, in terms of knowledge, in terms of modality. We could say that A1 gathers those elements that are necessary from our point of view. A2 contains all those points that are possible or may be accepted. So all those that are necessary are possible too, while A3 contains these elements of our universe that are rejected, and things that are beyond the union of A2 and A3, so all these other things, all these other elements are neutral. I defined some algebraic operations on triple sets. For example, the reunion, we have union of these components of necessity and possibility, while we have intersection of these rejection sets. Intersection in a similar symmetric manner, as you can see, we have so-called quasi-complement. We forget about A3 here, and we define quasi-complement as A2 complement, A1 complement, and A1. Then we have standard complement, as you can see here. We replace A1 with A3, and here in the middle we have complement of A2. We define empty triple set in the following way as empty, empty, and X, and universal triple set as X, X, empty. We use just empty set and X without any special added symbols. I think that the context will be enough to recognize that sometimes we speak about triple sets and sometimes about classical sets. One can easily check that this algebra is closed under these operations, and that union, intersection, and of course quasi and standard complement, that they produce new triple sets. Note that double negation doesn't necessarily return our initial set. So just like in intuitionism, not A is double negation in terms of quasi-complement is not necessarily A. This is written here, you can analyze this example. However, one can prove that triple negation in terms of quasi-complement gives us a singular negation, as the following identity holds for any triple set, and this is also somewhat like in intuitionistic logic. We can prove the following algebraic properties that are typical for distributive lattice: idempotence, commutativity of union and intersection, absorption laws, two laws, distributivity laws, which are here, and associativity, and the fact that A plus universal set gives us universal set, A and empty set gives us empty set, and so on. Then we should note the fact that the law of excluded middle and the law of contradiction are not necessarily true. And here you have some examples, some universe and some set. And one can easily check that the union of A and AC in terms of quasi-complement is not necessarily X, and their intersection is not necessarily empty set. However, some properties of complement are still true here, as you can see. And the Morgan laws hold too. But let us recall the fact that quasi-complement was based on the assumption that we forget about the third component. So we have a complement of A2, then complement of A1. Of course, the first one is contained in the second one, and we have A1, which has empty intersection with the complement of A1. But what is more natural, perhaps more typical, is this standard complement where we use all three components, as you can see here. So what are the properties of standard complement? For example, double negation in terms of standard complement returns our initial set. Negation, yes, complement of empty set gives us X, and negation of X gives us empty set, and this is always contained in this quasi-complement. De Morgan laws are true, but different excluded middle and contradiction does not necessarily hold in this framework. We can think about stronger version of empty set too. That would be zero containing only, composed only of empty set 3 times. And one can prove that its quasi-complement is just like its standard complement, it's zero. It's the whole universe. Of course, we mean triple universe here. You may check that, and this is not so typical, that the union of A and 0 is not necessarily equal to A, while the intersection of A and 0 is not necessarily 0, nor empty set, nor the standard empty set. We defined in our paper other algebraic operations too, int union and union int, as you can see here. They are rather specific and they are similar to some operations that we defined in terms of so-called negotiation sets. You can find a video on this topic on my channel. And we proved that the following hypothetical absorption laws are not true. So to a certain extent, these operations are dual to each other. As you can see, we have intersection of necessities, union of possibilities, and intersection of rejected sets. Here, this fragment is more complicated because we have intersection of possibilities, so we must be sure that the union of necessities, which is here, is contained in this new set here, yes. And here we have a union of rejections. Okay, so basically this framework can be used now, for example, in topological investigations, just like we have double and intuitionistic topological spaces, or neutral-isophic topological spaces and neutral-isophic crisp topological spaces. We can define triple generalized topological, supra-infra-topological spaces, generalized weak structures, minimal structures, and so on. And we can define the idea of triple points, just like they are intuitionistic and double points. As for the bibliography, Atanasov classical paper on intuitionistic fuzzy sets, Choker on intuitionistic crisp sets, 2 very important papers, Tantawi on soft double sets, and my own papers. The one which is here, it will be published. Today we are still waiting. Thank you very much for your attention as always.